Consider a plane lamina. X and Y are two mutually perpendicular axes. X and Y are two mutually perpendicular axes. Z is an axis which is perpendicular to both these two mutually perpendicular axes. As we have seen, Y and X are two mutually perpendicular axes. Now let us consider the moment of inertia about Z axis Iz. Moment of inertia about Z axis Iz. Now let us consider one more point P on the plane lamina whose coordinates are X and Y. We are calculating the moment of inertia at this point, and this is extended throughout the entire body. On applying Pythagoras theorem, OP square is equal to OA square plus AP square. That is, R square is equal to X square plus Y square. The process of calculating the moment of inertia is extended throughout the body. We are applying sigma. Sigma mr square is equal to sigma mx square plus sigma my square. Sigma mx square is equal to iy. Sigma my square is equal to ix. Therefore, iz is equal to ix plus iy. Inertia of a lamina about an axis perpendicular to its plane and passing through a point is equal to the sum of the moments of inertia about any two axes in that plane which are mutually perpendicular and passing through that point. Here Iz is the moment of inertia about a perpendicular axis to the plane lamina, and Ix is the moment of inertia about an x-axis, and Iy is the moment of inertia about y-axis. Therefore, Iz is equal to Ix plus Iy. Ix and Iy are two mutually perpendicular axes. Now let's move on to the parallel axis theorem. According to it, the moment of inertia of a rigid body about an axis passing through O is equal to the sum of the moment of inertia about a parallel axis passing through its center of mass and product of mass of the body and the square of the perpendicular distance between these two parallel axes. Let AB and EF be two parallel axes which are separated by a distance r. Let I and Ig be the moment of inertia of any axis and the moment of inertia about the center of mass respectively. Now let us consider a point P which is at a distance of OP from the axis of rotation AB. The right angle triangle OPD, OP square is equal to OD square plus DP square, but OD is equal to OG plus GD. OP square is equal to OG plus GD whole square plus DP square. Therefore, OP square is equal to, and applying the formula A plus B whole square, OG square plus GD square plus 2OG into GD plus DP square. Therefore, OP square is equal to OG square plus GD square plus DP square can be written as GP square. Therefore, OP square is equal to OG square plus GP square plus 2OG into GD. On applying the sigma, you can find out the moment of inertia of the lamina about an axis passing through, that is I. The bracket term indicates sum of moment of inertia about center of mass which is equal to 0. Therefore, sigma m OP square is equal to I, sigma m OG square is equal to IG, sigma m GP square is equal to MR square. Therefore, I is equal to IG plus MR square, where I is the moment of inertia about any axis, Ig is the moment of inertia about an axis passing through center of mass, and M is the mass of the body. R is the perpendicular distance between these two parallel axes. Therefore, Therefore, the moment of inertia about an axis, about any axis, is equal to sum of the moment of inertia about an axis passing through center of mass and product of mass of the body and square of the perpendicular distance between them. Hence, parallel axis theorem is proved.